Silicon is everywhere around us. It sits in beaches. It sits in deserts. It sits in mountains. Most of the time, we walk past it without noticing it at all. But this simple element changed the world. It became the foundation of modern technology. It became the material that allowed machines to think. It became the core of the digital age. In this documentary, we follow silicon's journey. From grains of sand, to the heart of every computer, to the center of artificial intelligence. This is the story of how a common mineral became the engine of modern civilization. This is silicon, the sand that became intelligence. Silicon begins its story in stars. Inside massive stars, atoms fuse under extreme heat and pressure. This fusion creates heavier elements. One of those elements is silicon. When those stars explode, they scatter silicon across space. Some of that silicon becomes part of planets. Earth is one of those planets. On Earth, silicon bonds with oxygen. This forms silicon dioxide. We know it as quartz. We know it as sand. For millions of years, silicon was simply part of the landscape. It had no special meaning. It had no special purpose. It was just there. But everything changed when humans discovered something unusual. Silicon could control electricity. Electricity needs control. It needs switches. It needs something that can turn current on and off. For a long time, switches were mechanical. They were slow. They were large. They wore out over time. Then scientists discovered semiconductors. A semiconductor is not a full conductor, is not a full insulator. It sits in between. Silicon is one of the best semiconductors. Its behavior changes when we add tiny amounts of other elements. This process is called doping. With doping, silicon can become electron-rich or electron-poor. It can form junctions. It can amplify signals. It can switch current on and off. In 1947, researchers at Bell Labs built the first transistor. It was a small electronic switch. It was fast. It was reliable. It was the beginning of modern electronics. Silicon was no longer just sand. It became a tool for controlling electricity. Early transistors were built one by one. Each transistor was a separate component. Engineers connected them with wires. This worked for small circuits, but it failed for large ones. The world needed something new. A way to build many components together. A way to make circuits smaller and faster. In 1958, the integrated circuit was created. It placed multiple components on a single piece of silicon. No more hand wiring. No more fragile connections. This was the birth of the microchip. It changed everything. Computers shrank. Electronics became portable. Spacecraft became smarter. The digital revolution began. Silicon was now the foundation of modern computing. Turning sand into a microchip is a complex process. It begins with extremely pure silicon. This silicon is melted, is formed into a crystal, is sliced into thin wafers. On these wafers, engineers build structures measured in nanometers. These structures are smaller than bacteria, smaller than viruses, smaller than wavelengths of light. The process uses several steps. Photolithography. This step uses light to print patterns on the silicon. Etching. This step removes material to create tiny shapes. Doping. This step adds atoms to change electrical behavior. Deposition. This step adds layers of metal and insulation. Planarization. This step polishes the surface until it is perfectly flat. Layer by layer, the wafer becomes a city of transistors. Billions of them. Each one is a tiny switch. Each one can turn on or off in a fraction of a second. A modern chip is one of the most complex objects ever made. And it all begins with sand. In 1965, Gordon Moore made a prediction. He said the number of transistors on a chip would double every 2 years. This became known as Moore's Law. For decades, engineers made transistors smaller, from micrometers to nanometers to near atomic scale. Each shrink made computers faster. Each shrink made electronics cheaper. Each shrink opened new possibilities. But shrinking forever is impossible. Atoms have limits. Heat becomes a problem. Quantum effects interfere with signals. So engineers change direction. They built 3D transistors. They stack layers. They used new materials. They created chiplets. They used AI to design better chips. Silicon continued to evolve. And so did the world built on top of it. Today, silicon is everywhere. It runs our phones. It runs our computers. It runs our cars. It runs our hospitals. It runs our financial systems. It runs our communication networks. Every message you send passes through silicon. Every photo you take passes through silicon. Every search you make passes through silicon. Silicon is the nervous system of modern civilization. And now, silicon is powering artificial intelligence, neural networks, machine learning, large-scale models. All of them depend on silicon. Billions of transistors work together. They perform trillions of operations per second. They allow machines to recognize patterns. They allow machines to learn. They allow machines to assist us. Silicon has become the medium through which humanity extends its mind. Silicon dominates today, but researchers are exploring new materials. Graphene, a single layer of carbon atoms with incredible conductivity. Photonic chips, chips that use light instead of electricity. Quantum processors, machines that use quantum physics to compute in new ways. Neuromorphic chips, hardware that mimics the structure of the human brain. Biological computing, using DNA as storage and logic. Will silicon remain the main material, or will it become the foundation for something new? The future is uncertain, but the search continues. Silicon is simple, it is common, it is everywhere, but it changed everything. It helped us build computers. It helped us build the internet. It helped us build artificial intelligence. It helped us build the modern world. From grains of sand to the circuits inside every device, silicon became the material that allowed machines to think. This is the story of silicon, the sand that became intelligence. Thanks for watching, and I'll see you in the next chapter of this digital adventure.